This is the data management life cycle. So when you look at this, I'd want you to think about, what does data management actually mean for me? So the steps are fairly self-explanatory, but I think the point that I want to make around this cycle is that it relies on three things predominantly. So it relies on people, it relies on processes, and it relies on tools. So at heart, I firmly believe, of all the researchers I've met over my lifetime, researchers want to do the right thing with their data. So what we need to do is create processes where that's enabled, where we can enable people to do the right things with their data. Once we have the processes alongside that, we actually need the tools. So in order to do the right thing, you need the tools. You need the tools to be able to analyze your data, aggregate your data, store your data, archive your data, and even destroy your data. I'll go through the carrots first. So for the Soil CRC, it's important for the Soil CRC to have a record of the research, and that can be for commercial products, so attributing IP. But it's important to note that even that data that isn't specifically IP or attributable or for commercial products, that data is just as valuable, right? That data allows for people to collaborate, for more research to be done, for decisions to be made. So it's across all, it's all data. We focus a fair bit, I find, in this space on that data for commercial products, but note that all data is valuable in some way. The CRC also will have contractual and legislative requirements. There's something about sharing data and advancing the sector as a whole. And they also, through the contracts that they have ownership of that data, of the data produced within CRC projects. For the researcher, having a single source of truth, so having that one data set that's high quality and is your single source of truth, I think is a carrot, as well as understanding what your obligations and responsibilities are around the ownership of your data, being able to store that data safely. That's both a carrot as well as a legislative requirement. You'll be able to tell from all the data breaches we had, people don't like it, and it's against the law. So there's stuff around security and privacy. You need good data to publish, and we'll come on to what is actually required in that publishing space in a moment. Sharing both internally and externally for collaboration and reuse of data. Those are the carrots. But of course, one of the things that it seems to be written in contracts all the time, but I think it's kind of glossed over. So every researcher in Australia is bound, whether that's in an institution or an organisation, is bound by the Australian Code for the Responsible Conduct of Research. It's a government code, and that code expects you to do research data management, or expects you to do good research data management. It asks you to keep clear, accurate, secure, and complete records. That's research data as well as primary materials. So your field books, your photographs, your samples, all those sorts of things. And also, where appropriate, to allow access and reference. So just to preface that and say, not everything is open access, and there are reasons for that, but where things can be made open access, they should be made open access. Is it all fit for storage? Firstly. So if I'm out and I'm taking photos of a weed, for example, and I take 25 photos and I upload them all, but 20 of those 25 photos are actually quite blurry and you can't see very much. So generally what happens is people upload everything because it's just, there's no curation of it all. And what that means is that within repositories, particularly within institutional repositories, that capacity is just becoming smaller and smaller as the data we upload becomes larger and larger. So I think the first thing to do is decide, is what I have actual data or is it digital debris? Right? If it's digital debris, find a massive magnet and just wipe it clean. But if it's valuable data, we will have an FAQ after this that will go onto that site, onto the Soil CRC site, to point you in the direction of trusted repositories, because that's the other thing. It's not just any repository, it's trusted repositories, and sometimes there are domain-specific repositories. So the other thing to think about is, what is the final data that I'm collecting, collating, producing? What is it that I actually need to keep, to store? Is it for a report? Is it for a thesis? Is it for a marketing document? What's it for? And that will determine what you actually need to keep, and what, if it's not of any use, whether you should consider whether to keep it or not. The only reason I speak about this is because across Australia, there's a statistic of, universities have about 3,000 petabytes of data stored across them. 300 petabytes. So if you think about a petabyte as being, those big filing cabinets you used to have, if you think about 20 of those, that would probably be a petabyte of data. So about 500 billion pages of data, that would be 1 petabyte. And we have about 300 in universities. So, and that costs universities to store them. So I think that in the future, if we want to store data, we need to get smarter about how we store it and what we store, because I think that universities in the future will be considering those sorts of storage costs. Do you know where in your institution you actually store data? So where is a good place? What is good research data management practice? Is it the OneDrive? Is it the SharePoint? Is it the FigShare? Is it the USB? So metadata, what is it? Essentially, it's information about your data. So here's your data, here's your metadata. So like Richard was saying, there's other stuff that goes with the metadata, like the grey data. Where does that, the contextual data, where are we putting that? Have you thought about where you're going to put that? So if you're just putting something like a pH number up from a soil test and somebody else looks at that, that actually doesn't mean a whole lot unless it's got some sort of context to it. Otherwise, it's just a number. So we need to be thinking about, in terms of the metadata, the actual metadata, which consists of three fields, which Nathan will go into in a minute, but it's essentially a descriptive field, administrative data, and structural data. That is what will form your metadata, and we'll give you examples of those. But also think about, is there contextual data that I need to add with this data so that it makes sense to somebody who's coming in and having a look? So Vegemite turned 100 years old on the 25th of October. And this slide, the reason it's really cool is because Vegemite will give you a fantastic example of metadata. So it has descriptive metadata, which is what it actually is, where it was made, the date and time that it was made. You turn the jar around, you've got your technical metadata. So the ingredients, the content, so things like README files, this will be things in the metadata space of where to store, how to manage, data models, user limitations. It has access rights. So trademarks and licensing are on your Vegemite jar, branding and labeling, and a barcode. So if you scan that, you'd actually know exactly all sorts of information about rights around what you can do with Vegemite. Preservation metadata, so the best before, use, end date. Think of your Vegemite jar when you're thinking about creating metadata, as well as provenance data. So lineage of the data, who owns it, what certifications are, where it comes from, that sort of thing. So this graphic will remain on these slides, and these slides will be uploaded onto the CRC website. And it's a great graphic for helping you decide, or helping you think through and see all the different kinds of licenses there are. So particularly, I've noticed in the recent contracts from fairly large funders, they're asking you about third-party data, and they're asking you to state the licensing on third-party data. What you might, in addition to deciding on your own license for your own data, what you might want to have a look through when you're looking at contracts is what the funder is asking you around your own data and third-party data, and whether that licensing that they're asking permission to use and to make it open access, whether that is actually what your data is licensed to do or that third-party data is licensed for before you sign that contract. Lots of different choices around licensing. We recommend Creative Commons license. It's what we use in a lot of our work. It's just a little bit firmer, more firm than copyright, but you will need to check because, again, within your own institution and within your project and within contracts that I've seen, some contractors actually ask for specific licenses. If in doubt, contact. Good place to start is if you're in a university, is your university library. They generally have people who can advise you on licensing. And you need to check those contracts because if it's not specified, go to your university if you don't know what license to use. And they generally recommend a Creative Commons license of some sort. I'm just going to move this box. Another thing to think about is, how am I going to share my data? Whether that's internally, so some systems like I've had difficulty with some university systems. I put the data in and it allows me to share internally, and that's fine if I give the right permissions, but it doesn't allow me to share externally. So if I'm collaborating with somebody at another university or another organization and we're working together on a data set or something like that, there are difficulties in sharing externally. Again, your IT department or your university, if you're in a university, your university library will be able to help you to work out the best ways if you're sharing internally and externally as to where you put your data. Whether you give them persistent identifiers, which is, think of it as the fail-safe to a URL. So URLs break, persistent identifiers do not. So it just helps people identify specifically objects, people, things. And I think of it as a hierarchy almost. So you'd need a digital identifier, or DOI as we call it. So those are identifiers assigned to a particular data set, and they would stay with that data set regardless of where that data set goes, so that they can be findable easily within a digital context. It also means that they can be correctly attributed and cited. So you'd need, when you're thinking about publishing your article or your paper or whatever it is, you'd want to link your DOI, so you get your paper out, you get your data set out, you go to your university. Most universities, in fact, all the ones within that we surveyed within the CRC, they mint DOI. So they will help you to get a DOI for your data set. So if you have not got an ORCID ID, I would strongly advise you to get one as a researcher. That is a permanent identifier for you as a researcher, and that will follow you through your research career. So anything that you publish, you can put your reports onto that ORCID ID. You can link your DOIs from your publications to that ORCID ID so that you are correctly cited. And journals will ask you for things like your ORCID ID, and that helps you create a really lovely portfolio of work, particularly if you're a graduate researcher or an HDR student. Even things like your presentations from conferences, they can also be linked to that ORCID ID. So just a few things to think about. What do you look for when you're using other people's data? What makes it easy to use that data? So it's around that findability and reusability prospect.